Is it recording? Okay, so it's recording. So start a new schematic first after open LTSpice. And press F2 to open up the library. And for example, right now we are building an AND gate. So you need NMOS transistors at the bottom. And they are in series. And press F2 to bring up to PMOS transistors. And so in LTSpice, the rules are, the gate is usually close to the source. So we want to rotate it and then mirror it. So when you are rotating it, you are pressing Ctrl R, and you mirror it, just click this button so you can mirror it. And we don't even need to load the model file. We can directly use the default devices. I don't think there's any problem with it because it's just a digital circuit. There's no analog stuff involved. Press F3 so you can make the connection between all the two VDDs, the power supply, and short these two parts. And here to here, here to here. So that's the first input. And that's the second input. And label it. Right click to change the name. B. F3 to wire it up and label it the out. And the body, the substrate connection being shorted to the highest potential of the circuit. This is the digital circuit class, so you don't have to understand, semiconductor stuff. Why do you have to do this? Just do it. Just short the P substrate to the highest potential of the circuit. When in the future, when you are taking analog electronics, you understand why you have to do this. Okay. And F3 for the NMOS, the substrate connection should be shorted to the lowest potential of the circuit. So this is V low, and this is V high. The reason we are not directly draw a ground pin here is because if I draw a picture for you, understand that. So in any of the electronics labs, if you have in any of the circuit classes, a lot of times you are going to use IC chips, IC circuit. So, the IC chip has all the pins available. But the thing is, the IC chip itself doesn't have a ground and the power supply inside. It's a tiny chip. So it only has all these pins available on the chip, okay? And you have circuits inside. It can be any of the circuits. I don't know what are they, but it can be any of the circuits. So for the chip designer, the circuit designer, they do not have to connect the physical ground or power supply to the circuit inside the chip. They only need to make the pins available, because the user can connect the power supply to the pin in the future, and the same serial to the ground. So the user will do that. And definitely you are not able to embed any of the voltage source and ground inside the chip. So you only need to make the pins available. Okay. So the same concept over here. Imagine that you are making a chip, IC chip. Okay. You do not, well, you don't have to, and you cannot actually put a ground over here, right? Because the user will do that. You cannot define this pin to be 0 volts. And the same thing here. You cannot put a voltage source over here. So the only thing you can do is make the pins available for this chip. So pin A, pin B, pin VCC, pin GND, and pin V out. So here's the V high. That's the pin available for this integrated circuit. And you need another pin, V low. And the thing is, V low doesn't have to be ground. If, for example, the user do not want to short the V low to the ground. They just want to short it to somewhere else. So for the user, for the designer, you just need to make the pins available for the users. But however, this is a NAND gate. If you want to build an AND gate, you have to invert your output. So what I will do is I will disconnect this part and copy the PMOS. I just need to build an inverter over here, right? So the PMOS and NMOS. And F3 to make the connection and short the two gates together. So that's the input of the inverter. And short the power supply to the same V high. And short the lowest potential to the same below here. And this is a substrate connection of the NMOS should be shorted to the lowest potential, which is V low. And that's P substrate connection of the PMOS should be shorted to V high. And the output of the inverter will be the final V out. Let me label that V out as well. We didn't even define the size of the PMOS and NMOS. If you came from my analog, you must want to change the name to P_1U or N_1U. But that's fine. It's a digital circuit. We're just trying to verify the logic. You don't have to. You don't even have to change the size of the PMOS and NMOS and also change the model. It's going to directly use the default model inside LT-SPICE. So let's directly just use them, and you don't even need to load the model file here. But it's better to do that. But if you don't do that, it's fine. Okay. So the circuit is done. I'm going to save it to, for example, my desktop. You want to save it to the same folder as your symbol. We don't have the symbol yet. But now let's save this one. Let's just call it AND-gate. And I save it on the desktop. So here. Now I can come back. What I want to do is directly create a symbol out of it. So new symbol. And then draw AND gate shape. So the shortcut is L is for lines. I just press L. L for lines. Here. And keep in mind that the shape doesn't have any electrical connections. So which means the shape, they are just lines, they're drawings. And circle, I need an arc for the AND gate. So what I will do is like this, and click here to define the arc. All right, escape, and move this arc to here. So that's the AND gate. And line, again, draw a line here for the one of the inputs, another line for the output. So far, there's no electrical nodes or connections at all. They're just a shape, lines, drawings. If you want to introduce all these input-output pins of your circuit, so what you need to do is go to I forgot where, but it should be pin, right? So the shortcut is pin. Let me press pin, P. Wait, P. All right. The name has to match with the circuit inside it, right? So whatever I just built, the AND gate. So I have A, B, V high, V low, and V out. So A first. So now I have your first electrical node. And P again, B, and P again, V out, P again, V high, P again, V low. You are supposed to make the connection, just draw a line here, but actually, if you don't draw a line, it will still work because, the line is just a drawing. Right? You can draw anything, any shape, but this is AND gate, you have to draw AND gate shape. Just in case people don't know what are these pins, you just want to show the name. So I think it should be like this, right click, and just make the name of the pins visible. Right click, right click. And save. So it's asking you where you want to save it. So you want to save it to the same directory as your circuit and the same name as well. Okay, AND gate. And now you can close these two circuits and start a new schematic and save it as, just save it to the same directory. I just do a AND gate simulation, okay? And press F2 to turn on the library. And you can see that your symbol you just built is not here, but you have to find it from here, drop down menu. Desktop, you find out AND gate. So place the AND gate in this new simulation schematic. And now you can put the power supplies and signal inputs to here. So open the library, excuse me. Open the library and go back to the regular library and go to voltages. So you need how many voltages? Anybody knows how many voltages? How many?
3.
3, yeah. A, B, VCC, VDD, right click, rename it as B, right click, VDD. So now you need a ground because that's the user end, right? So the user is trying to use your chip. Looks bad. Let's undo it and wire this out first and ground it. So here you need to know the A and B inside the symbol is not available here in this upper layer. which means you define this node here as A. It's not actually electrically connect to this A. So what you need to do is you need to wire this out first in this upper layer. We can say it's a higher hierarchy. It's compared to the symbol itself, this simulation layer is actually higher on top of this symbol. So need to rename the pins, rename the whatever label you want to use, right? So keep in mind, don't forget to connect the wire to it. And copy. Okay, so now they have electrical connection now. A to A, they're shorted. B to B. VD to VDD. And we haven't defined VOut yet, because the VOut you are seeing here is the VOut inside the symbol, and it's not visible here in this upper layer. So you want to label it so you can see the name in your simulation. Whenever you see a signal, it has a name, which is VOut, so you'll know what is that. So let's power it up using 5 volts VDD, and let's provide 2 signals. So what I prefer is I prefer using a series of pulses because you can see they may have some overlaps, and you probably can directly run all these possible combinations of the 2 inputs from 0, 0, 0, 1, 1, 0 to 1, 1. If you're using DC voltages, which is fine, but you have to probably run 4 times because all the voltage inputs are static voltages. They can only simulate 1 combination at 1 time. So let's see. I'm going to right click it and go to advanced and pick up pulses. So the initial voltage at the very beginning, let's just use 0 volts. And V on, let's do 5 volts. When the pulse voltage is turned on, it's 5 volts. And T delay, let's do 0 volts, so no delay. And T rise, I will just use 1 nanoseconds. T falls is also 1 nanoseconds. T on, I will do 1 microseconds. And T periods, let's make it a little bit larger than twice as much as T ons. So 2.1 microseconds. And what I will do, I will directly copy this SPICE code. And you don't have to type everything in here. So I just keep it empty. You know, this is a little trick. And right click the SPICE code and copy and paste. The one you just defined for the other one, for V1. And the only one you want to change is the time delay. So this is the 0 volts starting with 0 volts, and on T on is V on is 5 volts, and time delay for the first one is 0 seconds. So now let's make a time delay, so we can make all these possible combinations of the logic. Because the period is 1 microseconds, so what if we make a 0.5 microseconds? Let's see it. I don't know. Let's see if we can make all these combinations of the inputs, logic inputs. And I want to do a dot trend and start from 0 seconds to like 10 microseconds, and average 0.001 microseconds. I'm going to plot the point, maybe more. All right. So that's a simulation command. And I will directly run it. And I'll right click. And I will add a plot pin, because I know I'm going to have 3 signals, A, B, and V out. So right click and add plot pins. And for the first one, I will probe A. For the second one, I'm going to probe B. And for the third one, I want to select it first and then probe it. So that's all these results. Sometimes it's hard to see because you can see that it's being overlapped with the boundaries over here. So we can make the range to be a little bit larger. For example, 0 to 6 volts. Same here. So you can see the signal lines. So now let's check. For VIVB, do we have 0, 0? Yes, we do. So this period, this range is 0, 0, 0, 0. And for the AND gate, 0, 0 should be 0. So you're getting 0 for the output, which makes sense. And 0, what about 0, 1? So I have 0, 1, and the result is 0. And 1, 0 is also 0. Only when both of the inputs are 1s, you're getting 1s. Only this period, you're getting 1s. So the logic is verified. This is how you do this simulation. It's the same concept as the OR gate. Okay. For example, if in the midterm exam, and I give you a logic expression or give you an unsimplified logic expression and ask you to simplify it, and then design the circuit in LT-SPICE and simulate the logic to verify it's correct. Are you able to do that? So here's the question. So after this office hour, make sure you are going to practice on this on your own. And if you still have problems, feel free to ask me. I can show you more examples individually. We can set up a meeting or whatever you need. All right, any questions? Any other questions or anything?
So I have a question.
Yeah.
So when it comes down to do the drawing for the circuit, you don't really care the shape of it?
Yeah, you have to make it professional. I mean, literally, you can do anything. You can draw a dog, a cat, right? Whatever you want to draw, it doesn't matter at all because the drawing is a drawing. But you want to make it. If I am asking you to draw AND gate, you want to draw AND gate. You need to know what the AND gate looks like. You know.
Okay.
You know, just in the future, you're doing the job interview, like they want to ask you to draw some gates, you draw a dog over there, right? Say, you know, it doesn't matter, but you want to keep the good practice.
Right. Okay.
Is that clear for everybody who are new to LT-SPICE?
Yeah, that's clear for me. Thank you.
Okay.
Can you just quickly go over CMOS and PMOS?
CMOS and PMOS.
Like, how exactly do you know how many you need in the circuit?
Oh, for the circuit for here, did I explain this in the videos?
You did, and I do need to rewatch it, but
Oh,
can
yeah.
you just quickly explain
of course.
again?
So the logic is based on, so for example, right, for this part, if you give, if you turn on, yeah, I have to draw it, actually. I have to grab a paper saying, let me get a paper. So that's the theory of the gates, right? So why do we design the gates in this way? Camera. All right.
think. Dr. Lee, I'm not hearing you. Not hearing you. I don't know if it's just me.
No, I don't know why. Okay.
Okay, there it goes.
Mm-hmm. Yeah, if you haven't running out of time, if I terminate the meeting, I'm gonna reopen the meeting. Can you come back again later?
Yes.
Okay. Let's keep going. So that's a non-logic. Agree with that?
Yes.
All right. So when the two inputs are zeros, you want to turn on the V out.
Mm-hmm.
Mm-hmm. So if you have two PMOS on the top, so you're asking why do you need two PMOS? Because I have two inputs, right? So that's why I need the two PMOS. Two PMOS will provide you two gates. It's like a switch for the faucet, right? So one is controlling one. If you have two, it's controlling two. And the PMOS is being shorted to VDD. And only when you are giving two zeros here, and you are turning on these two PMOSes, and you are shorting your V out to the VDD. So that's why you are getting a logic high, which is one for the V out. And at the same time, you want to turn off anything being shorted to the ground. And this, if you have two NMOS doing this, so 0, 0 will turn off the NMOS. So V out will not be shorted to the ground, but only these two are open to the VDD. So you're getting a voltage high. So this logic is verified. If either of the A and B is 0, you can see you have two channels. They're in parallel. And they're both being shorted to the VDD. If you open either one, it's going to short your V out directly to the VDD. It's like two highways to Denver, right, from Durango. If one is open, it just goes through that way, you can go to Denver. Because they're in parallel, right? If only one, either one is open, so you need a 0 volts to open the PMOS. Either one is open, you are getting a VDD, voltage high, logic high for the output. So verified, right? The only way you can get a 0 for the output is you have to turn on both of the NMOSes because they're in series. There's just one road, one highway go to Denver, so, right? You have to turn on both of them in order to short this to the ground. And when you are giving 1, 1 to the NMOSes, you turn on this channel, so it's being shorted to the ground. And at the same time, these two ones will close the two PMOSes. So there's nothing affecting your V out going to 0, right? So both of these two are shut down. So it's not going up, but going down. It's being shorted like a wire. So some people have been trying to use how to design a three input NAND gate, right? A, B, C, D, 0, 0, 0, 0, 0, 1, 0, 1, 0, until 1, 1, 1, like this. So the way to do that is just draw 3 PMOS on the top. And 3 NMOS at the bottom. Here's V out. So the logic here will be A, B, C, NAND equals to V out. But a lot of times, you know, for example, the IPGAs or the programmable gate arrays, they prefabricated all the gates inside. So actually, you are not actually designing this manually by yourself. So what they will do for a 3-input AND gate is they are going to use 2 stages, A, B, C, and invert it. So this output will be ABC, not. So every single AND gate here is a 2-input AND gate. And from here to here it works, from here to here it works, so this works, right? And it's not going to change too much. So just memorize that. You just need to verify this one time and memorize it and understand it you can understand in the future. But you don't have to think about how this works all the time during exam or when you're designing any circuits, right? It's just, you know it's gonna work. Just use it, right?
Yeah. I think I was just confused on how to put that into LT space.
Oh,
That's,
this one?
yeah, I think that's what my problem was.
Oh, yeah. I just recorded. Did you watch this? You were here, right?
Yeah.
Yeah. Yeah, no worries about that. You are really new to this. I mean, for all the other people, they have been using LT Spice for a year, sometimes in 2 of my classes, right? It's a open source simulation tool. It's pretty good, I think.
Okay. I think that clears it up a little bit better, so thank you.
Yeah, no problem.
And when are we to resubmit our homework
Mm-hmm.
problems?
Yeah.
When would you like?
Yeah, as soon as possible, like tomorrow. What you want to do, because Friday you are going to take the midterm exam, right? If you want to get feedback, you want to turn it in like today or tomorrow probably. So
Okay.
I will see if you still have any problems in anywhere in the simulation.
Okay.
Mm-hmm. I think I have 2 minutes. The meeting will be terminated. I'm going to reopen it. If you still have questions, you can come back.
I have a quick question.
Yeah, what's that?
Are you gonna resend the homework back with feedback and to see where we actually messed up?
I did. Did you see that? I did it in Canvas. You didn't see your feedback?
I don't think I was able to see mine. I'll double check again.
Did you see I put a score on that and some
I
comments?
see the grade. I saw the grade, but I didn't see like,
The
I don't know if
marks?
get a PDF and put notes on it and send it back.
What about other people? Did you see a score on the PDF? Or
I saw this. Yeah, I saw the score in the comments.
But you didn't see any marks in.
Oh, I did see the marks.
You did or you didn't?
I did.
Okay, you did. Great. I don't
For
know.
our resubmission, do you just want us to turn in the 2.4 and 2.5, or do we need to turn in everything again?
Yeah, just 2.4, 2.5. Whatever you need me to regrade it. Just turn in that one.
Okay.
Yeah. If you did all the other ones right, you don't need to do that. All right, let me restart the meeting. And if you want to come back, just come back, all right? I will stop recording that. Otherwise, it will be too long.